Hello everyone. In this video we'll study the increasing and decreasing functions and its critical points if it exists. Find the critical points, then determine the increasing and decreasing intervals of each of the following functions. Question number 1. Here we have f of x equals x over x plus 2. Now let us go to solution. Next page. Here we have f of x equals x over x plus 2. The first step here, we must determine the domain of the function. So putting x plus 2 equals 0, then x equals negative 2. So negative 2 makes the denominator equals 0. So you can say that the domain of f equals r difference negative 2. So the number negative 2 is out of the domain. Second step, we must determine f dash. So f dash of x, here we have a fractional function. So to find the first derivative, we write the denominator x plus 2 multiply the derivative of the numerator. Here we have the numerator equals x, its derivative equals 1, minus the numerator x multiply the derivative of denominator, which equal 1 plus 0, because the derivative of x is 1 and the derivative of 2 equals 0, all over x plus 2 all power 2. And we simplify it. We have x plus 2 multiply 1, it is x plus 2, minus x multiply 1 plus 0, it is negative x, all over x plus 2 all power 2, and the result equals 2 over x plus 2 all square. Here f dash not equal 0, and f dash of x is undefined when x equals negative 2. So we write f dash of x is undefined when x equals negative 2. But negative 2 doesn't belong to the domain of x. Negative 2 doesn't belong to the domain of f. So f dash not equal 0, okay? And the f dash also is undefined when x equals negative 2. But negative 2 doesn't belong to the domain, so there is no a critical point to f of x. So you can say there is no critical points to the function f. And now we will determine the increasing and decreasing intervals about the point negative 2 using the number line. Here we draw the number line and we write x, f of x, and the f dash of x. Here we have when x equals negative 2, f dash of x is undefined, and you can write it does not exist. Now we will determine the sign of f dash of x about the point negative 2. We choose two numbers belong to the two intervals. Here we choose a number like -3 and another like -1. Here -3 is less than -2. It is belong to this interval from -infinity to -2, and -1 belongs to another interval from -2 to infinity. Now, f dash of -3 equals 2 over -3 plus 2 all square, and this is equal positive 2. Okay, so you can put positive signs here, and f dash of -1 equals 2 over -1 plus 2 all square. It is equal also positive 2, and you must consider the sign here and here, so it is also positive. And now we put some arrows. You can say the function is increasing here in this interval, and we write it. So f of x is increasing on the two intervals. The first interval from -infinity to -2, it's open, and from -2 to infinity, and there is no critical points. Next question. Question number 2, we have f of x equals x squared over x minus 2, and also here we determine the domain. How you determine the domain? Putting the denominator equals 0. So when x minus 2 equals 0, then x equals 2, and then the domain equals r, the set of real numbers, except 2, difference 2. So the domain of the function, denoted by the symbol d, equals r difference 2. So the number 2 is out of the domain. Now we find the first derivative, f dash of x equals, here the denominator x minus 2 multiply derivative of numerator. It is 2x minus the numerator x squared multiply the derivative of denominator. It is 1 minus 0 over the square of denominator x minus 2 all power 2. And we simplify this fraction. So x minus 2 multiplied to x, it is 2x squared minus 4x minus x squared multiply 1 minus 0, it is negative x squared over x minus 2 all square. And now it is equal 2x squared minus x squared equals x squared minus 4x over x minus 2 all square. Here putting f dash of x equals 0, It is a very important step. So we write f dash of x equals 0. That means x squared minus 4x over x minus 2 equals 0. That means x squared minus 4x equals 0. So by taking x as a common factor, what we get? X minus 4 equals 0. So x equals 0 or x equals positive 4. And both 0 and 4 belongs to the domain. So you can say there is two critical points when x equals 0 and when x equals 4, and we will determine it. So the two critical points are 0 and f of 0, which equal 0, and f of 0 equals 0 square over 0 minus 2, which equal 0. So this is the first critical point. And the second critical point is 4 and f of 4. F of 4 equals 4 power 2, it's 16, over 4 minus 2. The result equals 16 over 2 equals 8. Okay, so the second critical point is 4 and 8. Okay, and to simplify this part, we write 0 and 0, and 4 and 8 are two critical points. And here we have, back to f dash, here f dash of x, or here f dash of x equals x squared minus 4x over x minus 2. Also f dash of x is undefined when x equals 2, right? Here x not equal to, right? So f dash of x is undefined when x equals 2. It is undefined, but 2 doesn't belong to the domain. So you can say that there is no critical point when x equals 2. Okay, because 2, it is out of the domain of f of x, right? Okay, and now we make this table to determine the increasing and decreasing intervals. And here we write x, f of x, f dash of x. And f dash is undefined when x equals 2, right? So we write here 2, and the f dash of x is undefined here, or you can write not exist, as I said before, undefined here. And the f dash of x equals 0 when x equals 0 and x equals 4, and we write here 0 and 4. and we write f dash of x here equals 0, and also here equals 0. So now we check the signs of f dash in these intervals. Okay, we have 4 intervals, 1, 2, 3, 4. Okay, the first, it is from negative infinity to 0, and here to from 4 to infinity. Now we choose a number belonging to this interval, like negative 1, and another belongs to the second interval, it is 1. Third interval, we choose a number like 3. Fourth interval, we choose the number 5, and we check the sign for f dash of x. Okay, here we have f dash of x equals x squared minus 4x over x minus 2 all square. Note that x minus 2 all square, it is the denominator, always positive, right? Always positive. So the sign of f dash depends on the numerator. Depends on the numerator. So we substitute. Here we have x squared minus 4x equals negative 1 all square minus 4 multiply negative 1. And this quantity is positive. 1 square plus negative 1 square plus 4, it is 5. So the sign here is positive. Okay, and when x equals 1, so we write 1 power 2 minus 4 multiply 1, it is negative. It is equal negative 3, right? And we take 3 here, 3 power 2 minus 4, 4 multiply 3. It is 9 minus 12, it is negative 3. Here it is negative. And we take negative here. Finally, we take 5. We have 5 power 2 minus 4 multiply 5. It is 25 minus 20, which equal positive 5. So the sign here is positive. So f dash of x in this interval is increasing, decreasing. Also here it is decreasing and increasing on the last interval. And we write it here. F is increasing on the two intervals from negative infinity to 0, and from 4 to infinity, and f is decreasing on the two intervals from 0 to 2, and from 2 to 4. I hope you understand every step.